In working number 3, first of all, if you need to pause the video and read number 3, do so. I'm talking to the people who are watching this on the internet, okay? You're in here in class. Hopefully you've already read 3, but if you haven't, we're talking about outdoor and indoor shoes. We're talking about a 2-step process to make them. So I'm going to cut the room in half here. You guys over here on the right side of the room, you guys are step 1, manufacturers. On the other side, you're step 2. Sometimes with word problems, especially word problems, it's not like your typical math problem. Your typical math problem, especially if you're decent with math, you just start working it. You know what to do and you just do it. And you get the right answer. Or you get the wrong and you fix it, right? With a word problem, you have to step back sometimes and just get a feel for what's going on. So let's make one shoe, one outdoor shoe right now. If I make one outdoor shoe, it starts over here on the right side of the room in step 1. They do what they do. So maybe they make the sole of the shoe and they make the boot of the shoe, whatever, okay? And they're done with it, and it took them, for outdoor shoe, took them 2 hours. Then that shoe gets brought over here to the other side of the room where they put maybe the laces on it and put it in the box to, to go sell, whatever you do. But they spent how long with that one pair of shoes? Looks like in step 2 they spent an hour. So at least now in your mind you know what's going on. There's a manufacturing process going on, 2 steps. Shoes start over here on the right side, then they move over here to the left side. All right, now let's first define your variables, which I've already done for you. X is going to be the number of outdoor shoes and Y is indoor. So X, number of outdoor. Y is the number of indoor. We now look for phrases that limit your production. And there's only 2 of them. When you reread this problem, the company has 40 hours of labor available per day for step 1. That phrase is a limit on how much production you can make. You can't use over 40 hours in step 1. So that phrase, and then of course the next phrase, 60 hours in step 2, those are your 2 phrases. 40 hours available, step 1, 60 hours available, step 2. Some of you are good enough at writing these inequalities that you don't need what I call the concrete example. You could just write the inequalities now because you know what to do. But if you're struggling with what do you do with that information to turn it into a line to graph, here's a suggestion. Pick 2 numbers that aren't already in the problem and use those as an example. 10 and 20 or 10 and 30 are not in the problem, so I'm going to use 10 for outdoor shoes and 30 for indoor shoes. And I'm going to think about this first phrase only. Can I make 10 outdoor shoes and 30 indoor shoes if I've only got 40 hours available? That's a yes or no question, right? Can I do it? Now, go back to the problem and figure it out. Go back to the word problem. For 10 outdoor shoes, 30 indoor. According to the problem, in step 1, 2 hours per outdoor shoes. So how long will it take to make those 10 shoes? 20. Okay, all right. Taking that back over here, you just did 2 times 20. I'm sorry, 2 times 10. All right, back to the word problem. The 30 indoor shoes, how long do they take? They take 30 hours. 1 times 30.
All right, for the outdoor shoes, it would be 2 hours, and then 1 hour would be 3 hours.
It's 2 hours in step 1. And we're only looking, that's a good question, we're only looking at one phrase right now. 40 hours available in step 1. So we are only thinking about that one phrase. The 40 hours that your company says this side of the room over here, the right side, you got 40 hours. Can you make 10 outdoor shoes and 30 indoor shoes? All right, so we got our 2 times 10. Now we got our 30, I think it was times 3. No, 30 times 1. because there's 1 hour required to make every indoor shoe in step 1. So we have just taken up 20 hours of the indoor process. 20 hours of the step 1 process, plus another 30 of the step 1 process. Can you do it? This side of the room, can you make that many shoes if you've only got 40 hours available? No, and that's not really the important part. Yes or no is not the important part. What you just did in your head to finish it. All right, sorry about all the pauses in the video. We have picture day, so we're having to pause. But anyways, you answered no, you can't do that because you added those two numbers up. And you checked to see if it was smaller or equal to 40. That's your inequality. The 10 is x. The 30 is y. So your inequality is 2x plus 1y, which is just a y. I'm not going to put a 1 in front of it. Less than or equal to 40. That's how a concrete example helps you write the inequality, because it feels more natural to use the numbers 10 and 30 and talk about the problem than it does x and y, which just represents any combination of outdoor shoes and indoor shoes. All right, a little faster on the next one. 60 hours available. So thinking about that phrase, 60 hours available, can you, in step 2, make those 10 indoor shoes, or 10 outdoor shoes and 30 indoor shoes? I don't know if I can, so I got to go back to the problem and see. So I'm thinking about step 2 only. Step 2 only. 10 outdoor shoes. The outdoor shoes in step 2 take an hour apiece. So those 10 outdoor shoes are going to take 10 times 1, 10 hours. The 30 indoor shoes. According to the problem, indoor shoes take 3 hours in step 2. So how long will those 30 indoor shoes take? They'll take 30 times 3. 30 times 3. Do you have enough hours? 60 hours available. Do you have enough to make that many shoes? No, because you're adding those two numbers, 10 plus 90, in your head. You're adding them and you're seeing if they're smaller than 60. Doesn't matter, the answer is no. You just wrote your second inequality. 1x plus 3y is less than or equal to 60. Now I'm going to go back to the word problem and cross out everything we've already used. All right, we've used the first sentence and the second sentence don't have any information that bears on our inequalities. We've used that. We've used that. So there's only two things left that we haven't used. Profit of $20, profit of $15, and the rest of the problem is just asking what's the maximum, right? So those two pieces of information, what were they again? $20 for the outdoor, 15 for the in, so $20 per outdoor, 15 per indoor. I think you're getting good enough at this. You don't need the concrete example to write a profit function. But if you do, those 10 outdoors are going to be multiplied by 20, and those 30 indoors are going to be multiplied by 15, and you're going to add those two numbers up to get your total profit. All right? The 10 is still x. The 30 is still y, so 20x plus 15y is your profit function. All right, question?
Is it always going to be money that you're phrased?
Is it always going to be money that you're phrased? Pretty much, yes, because it's either going to be profit, cost, revenue, something with money. Because if you own a business, you want to make the most money you can, and you're either going to do that by making the most profit you can or minimizing your costs. So maximizing profit, minimizing costs, that's your typical objective. All right, I'm going to stop the video there because the rest is just, oh, one more, sorry. I even have it right here. Don't forget the logicals. You can't have negative number of shoes, so x is bigger than or equal to 0, y is bigger than or equal to 0, and that just makes sure you're in the first quadrant there, okay? So I'll stop the video because that's the important part. The rest you can finish by graphing, find your coordinates of the vertices and plug them in, blah, blah, blah.